Hello and welcome. Thank you for taking the time to join us today as we talk about a revolutionary technology in textile finishing. I am your host, Sumit, and on behalf of Fiber to Fashion, I would like to introduce our panelists from Baldwin. First up is Mr. Wesley Clemens. He is the speaker of the webinar. Then we have Rick Stanford, Yanis, Alex, and Madeline. I would ask now Rick to take it forward from here.
Okay, first of all, I'd like to thank everybody for joining the webinar today. So I'll say good evening, good afternoon, good morning, wherever you may be. So we're looking forward to a great interactive webinar today. And our mission today is to discuss with you about a revolution in textile finishing. And we're pleased that my colleague, Dr. Wesley Clements, will be driving the presentation today. And Wesley has been somehow involved with Baldwin for more than 25 years. He actually started as a customer, if you will. So he's been on both sides of our business. And he's currently the global leader of our engineering and R&D team for Baldwin. And as you can see, he attended Queen's University in Belfast and has degrees, including a PhD in mechanical engineering. And the technical panelist for today's Q&A session, of course, myself, I'm responsible for the global business development for our textile business within Baldwin. I'm located on the East Coast of the US. We have Yanis that has more than 20 years experience in dyeing and finishing. He's in charge of our textile technology department, and he's located in Sweden, Arlöv, Sweden. And then Alex, who's been with Baldwin and Albrandt for more than 25 years. He's our product manager for spray and also for Corona plasma treatment, and he's located in Lauterbach, Germany. So for many of you out there on the webinar today, you may never have heard of Baldwin. And that's because we're fairly new to textiles, and I'll discuss about that in just a moment. But Baldwin as a company is more than 100 years old. We're a US-based company with an annual turnover of more than 165 million. You can see that we have more than 700 team members around the world, multiple locations, and we're in various industries, including printing and packaging, film extrusion, and some others. And we're part of a larger group, Barry Wade-Miller. You can see has more than 110 companies. So the Baldwin textile side of the business actually started in earnest at the ITMA Milan show in 2015. We took some of our technology out of our offset printing business to transition over to textiles. And I think now this is the point in the presentation. I'll turn it over to Wesley. Wesley, over to you.
Thank you, Rick. And I'd also like to say a big thank you to the Fiber to Fashion team, very professional in setting this up. And also a warm welcome to the participants, our customers. So good evening, good afternoon, good morning. Thank you very much. I think it's fair to say we all live in a world where there's a lot of discussion with regard to that involves the word sustainability. In particular, if we look at textiles, in our new world of textiles, the consumers are more and more informed about the environmental impact of textile industry, including waste, chemicals, energy, and especially the young consumers are increasingly aware. There's a lot of discussion on social media, etc. And the it's fair to say they're demanding action from the fashion industry to deliver sustainability. And these people are requiring real action, not just intent in annual reports. I think we also have to say there's a lot of good work going on within the industry, and it's our job within the industry to tell that story. So this is just to set the scene. So if we look at, in particular, today's subject is sustainability in textile finishing, and what does it mean? So in textile finishing, we apply a lot of chemicals that frankly require a lot of energy to produce. So it's important that we use them wisely. We apply what's required and we minimize the waste, whether that is generated by putting too much on the fabric or generated by going into the waste stream. There is a desire to get towards zero chemicals, a good desire, entering the waste stream, to minimize water footprint, to minimize the energy footprint, and of course, to provide a good work environment for the people who work in the mills. And as we move forward, there will be increasing demands for traceability. It's not just enough to say we're doing it. We also have to produce the data to say that this chemical was added to this chemical batch on a certain day. And that's, technology is making that increasingly possible. And none of us wants to have this greenwashing label that you hear more and more in the media. So it's about reducing waste, minimizing water, minimizing energy. Those are the main points that we would like to talk about this afternoon. We look at padding. It's been around for a long time. It's done a good job. But I think for those of us in the industry, particularly those working with natural fabrics, we know the pad bath gets contaminated with fabric particles. The chemicals, some of the chemicals have a tendency to coagulate within the bath, and for those people using biopolishing, that's generating a lot of particle load into the bath. That generates the need to replenish the bath on a regular basis. So there's a lot of chemical effluent just going in, driven by those changes. Could be on an open width 100, 150 litre discharge per change, and some simple math can show that can be up to 10% of the finishing chemicals that's coming into the facility is simply being lost in bath changes. And this is an energy intensive raw material that's wasted and generating an effluent stream. The wet and wet process, it's very widely used, and as I say here, in principle, is a very sustainable process, because we're going straight from dyeing without an intermediate drying step. So we're not wasting energy drying the fabric and then applying the finishing chemical. So it's inherently sustainable. But as most people are aware, using the technique, there's a continual transfer of water, both from the fabric and from the first pad into the chemical pad. So there's a continual dilution effect going on in the chemical pad, and that leads to this so-called tailing effect, where the amount of chemical applied in the pad deteriorates over time. That's compensated. I use the term overdosing. You add in extra chemicals and frequently refresh the pad. So this overdosing phenomena can add 20% more finishing chemicals than what's really required to do the job. And on this slide, which I suggest we go through more in detail, but it's up to 30% of the chemicals that's been added in the wet and wet process is is unnecessary, 20% from the overloading, 10% going to drain. And it can add up to some significant tonnage going into the wastewater stream over the course of a year. This example is for a 50-ton, medium-sized mill. As we share the presentation later, you can look through the numbers. So what we want to introduce this afternoon is, first of all, why non-contact spray helps solve some of these problems and therefore is more sustainable. And the biggest thing that helps the non-contact spray is literally there is no contact between the chemical being sprayed and the fabric. So this problem of the chemicals getting contaminated by the fabric particles, it goes away. So when we have a non-contact spray, you can have blue fabric followed by yellow fabric followed by pink fabric without having to change the chemical. You cannot do that in a conventional chemical pad. So, and also because the chemical is not being contaminated, whatever chemicals left in the system at the end, that can be saved and reused because it's not contaminated with fiber particles. The next slide will explain in more detail. What non-contact spray does is allow a uniform application through the batch. Let me try to explain. So if we look at the diagram at the bottom, we have the conventional water pad as the first pad, followed by the non-contact spray. And here again, the non-contact is the key. There's no mechanism for the water to come from the fabric back into the chemical. And because of that, if you start off spraying 12%, you end up at the end of the batch spraying 12%. So we have a much more stable process. It also means that you don't have to overdose to try to maintain the percentage. You set the grams per square meter that you want in the control system, and the system will do it all the way through the batch. Because you have consistent application of chemicals, in some instances with padding, people can experience shade variations between the beginning of the batch and the end of the batch. Those are nullified because we're spraying evenly throughout the batch. So basically what we believe is that non-contact spray provides a mechanism, a sustainable alternative to padding and exhaust finishing. So we go from a system that generates some pollution to a sustainable mechanism. And in the following slides, I want to explain a little bit more detail of what the system looks like and how it works, etc. So, as Rick mentioned from the beginning, at the beginning of the presentation, Baldwin brings 35, almost 40 years of spray experience to the table. Our spray technology, in particular, the spray nozzles that handle the liquor, they were developed for the offset industry, and we've had 35 years of opportunity to refine that technology, over 40,000 installations globally. We're the global world leader in spray technology for offsets with manufacturing plants in Germany and in Japan. And we've built up a lot of experience in that time and a lot of refinement in the manufacturing technique. And what that brings to the table is very repeatable nozzle to nozzle variation. So there's minimal differences between how the individual nozzles and how the individual valves perform. And what that means is it gives a lot of precision and a lot of repeatability, both across and from system to system. And in addition, we have a lot of in-house technology in terms of software algorithms to really maximize the control so that we get very precise metering of the liquid going through our systems. That's a little bit of the background. The system itself, there's three main elements. There's the, which I'll take you through in more detail. There's the spray chamber itself, where the chemicals, it's a sealed chamber where the chemicals are sprayed onto the fabric. We have a pump station that brings in the fresh liquor and also the recycled liquor coming back from the spray chamber. And then we have a user interface that is relatively simple to use. The spray chamber itself, there's been a lot of development, a lot of work put into the spray chamber. If we think about the people in the mill and the workers in the mill, it's very important when you spray that the spray is totally contained. And our spray chamber is a sealed chamber. It can open and close for webbing up the machine. And then it has specially designed rubber seals at entry to the chamber and exit of the chamber. And the chamber is designed that the fabric flows from the bottom to the top. We then have the valves are mounted in what we call a valve rail, and you can have either that on one side of the chamber or both sides of the chamber. So you can spray single or dual side, and with software you can from job to job you can switch from single side spray to dual side spray, so there's maximum flexibility. So the sealed chamber is an important mechanism, making it safe to spray finishing chemicals within the mill. We also have developed a very unique geometry in terms of how we arrange the overlap. The nozzles are designed to spray at an angle, so we create this virtual overlap, and what that has been demonstrated with a lot of development trials to produce an exceedingly uniform lay down across the fabric and along the fabric. The important thing also about this generation of spray technology is the nozzle spray technology. What it does, it sprays directly at the fabric. Other spray technologies such as mechanical rotors tend to have a more tangential action, but the spray leaving the nozzle is almost going directly at the face of the fabric. And what that does is gives us the opportunity for that we can control the penetration into the fabric using pressure. And we have many of our customers running tubular fabric, tubular fleece, heavyweight fleece, and they're getting good penetration into the center of the tube with over 400 gram fleece. And that's running daily, and the customers are very happy. I use it as an example that we have real data that shows that we do get deep penetration into the fabric. We also have a really good feedback from our partners in the chemical companies. We work with all the global suppliers, and one of the things that the Textile system brings to the market is very low shear stress influence on the chemical. And the key to that is that we have a very low circulation rate within the Textile system. Only the chemical at the edge of the fabric has to be, so we have a nice even spray right out to the edge, and then there's some overspray, and that's what gets recirculated back to the pump station. It's normally about 10% on a 2 meter system. And what that means is that the chemical, it just goes, for the most part, goes through the system once. It's not been repeatedly churned because it's been repeatedly cycled around the system. And that has given us the ability to spray a very wide range of chemicals and and with a good feedback. Perhaps Yannis, as the textile technologist, I can get you to give a little bit more detail on that.
Hi to everybody. Yes, I would like to thank you for joining us today. Yeah, I can talk about the. I'm sorry, Wesley. I just looking at the questions, so I miss your last words.
Perhaps you could talk a little bit about the low shear stress that we apply to the chemicals and how that is helpful to the.
Yeah, exactly. So what I would like to say today about the low shear stress. Usually the spray application technologies, I can say is not new technology, is many years on the industry, but for many years it fails when we have to apply finishing chemicals like silicones, macroemulsions, or water repellents with cross-linking agents, which are chemicals I can say sensitive on shear forces. So and that's let's say our system and the low recirculation amounts and the diaphragm pump, which you are talking to, which you will say to later on your presentation. It ensures that we will have a very gentle application, and we will have a minimum breakage of the emulsions. So we are able, and our customers successfully applied macro silicones, water repellents with cross-linking agents, especially when we are talking about C0 applications, where it's a must, the cross-linking, and to have the maximum of the performance of the water repellent and the durability of the product. So we have also developed a machine here in Arlöv in Sweden, where we can test the shear forces and the durability of the chemicals, and when we will spray, and the recirculation amount. So far, I can say that most of the finishing applications and the sensitive ones we can spray with very good results.
Thank you, Yannis. I appreciate that. Thank you. And to support that, so for example, if you have a 2-meter system and you want to run a 1.6-meter fabric, the system will automatically silence the outer nozzles. You enter the fabric width, and the algorithm will decide which nozzles are needed, and the outer ones will be silenced, so that we're not unnecessarily spraying outside the fabric and therefore generating a high recirculation flow. So every single valve on the system can be selected. So the system automatically compensates for the width as you run different fabrics in the batch, the fabric widths in the batch, right? And you know, just in support of that, we here in our labs in Sweden, Germany, and also across in Japan, we have tested with, as Yannis mentioned, with the ability to test from all the different manufacturers, and importantly, our customers, the approximately 80 systems out there on all continents. You know, there's a lot of people running softeners, as Yannis said, both micro and macro emulsions. Antimicrobials is quite important for some customers using our equipment. Water repellents, flame retardants, etc. So there's a lot of different chemicals running successfully and being used on a daily basis in our machine. We'll just touch on this briefly, but the spray chamber, the valves and nozzles. What we do is we mount the nozzles in what we call a valve rail, and it can be pneumatically retracted, and that allows a very easy viewing of the spray patterns. So that's very convenient at the start of the shift. It's obviously very important to see that the spray pattern is good. We make that very easy for the operator, and all the nozzles at the end of the shift, or whatever the desired maintenance interval is, they can all be removed easily from in a toolless fashion. It's a bayonet fitting, and so we put a lot of thought into making maintenance straightforward and easy for the operator. As Janice mentioned, we have a specially developed diaphragm pump to deal with the pressures, and also to provide a very pulse-free technology. But importantly, that continues with this theme. It's very important to build a lot of things in to make it easy to be able to spray these delicate dispersions, these delicate shear sensitive chemicals that Janis mentioned. So that has been really working well for us. We even though our recirculation rate is very small, you know, for those of you who are running you know, jersey, fleece, maybe with a little bit of biopolishing going on, there's a lot of fabric particle coming back to the pump station, and we provided a very large area return filter that can be easily cleaned on the run to make sure that the filter is not overloaded with the fabric particles coming off the fabric. And the system has automatic washing cycles incorporated into the pump station and into the control system. So if the machine is stopped for, say, 30-minute break, the nozzles can be automatically washed, and as you change from one chemical to the next, the complete system is well, first of all, the unloading of the chemicals is automatic, the washing of the system is automatic, and the reloading of the chemicals is automatic. So make it easy for the operator. And also then, if we look at overall the whole concept of minimizing chemical waste, well, a good starting point is to minimize what the stored volume is within the system. And the buffer tank that we have ahead of the pump has only got a 3-liter capacity, and its job is to blend the new liquid coming in, the new liquor coming in with the returned liquor coming back from this ride. So it's only a 3-liter capacity, and so that means when the job is over, we've only got 3 liters maximum to deal with. And what we've done is we've made it very easy if you choose. It's clean chemicals because it's again with the non-contact, it's not contaminated. So you've got a very easy capability to manually capture those 3 liters as you change from one job to the next. So we've made that relatively easy for the operator to do. I'd like to stress that first of all our systems out there have been retrofitted, and the system is relatively easy to mount into existing lines, and we'll be doing this both in open width and tubular pads, and we have a series of designs for that support us. These open width systems is typically 2 vertical supports to mount the shrouds and the pump station. So it's engineering that's typically available within the mill and our support technician when they arrive. So the average install of the preparation is done, takes 1 day, and then the focus of our visit can be on training and refinement of recipes, etc. So up to now, I've talked mainly about the application as it relates to wet applications for natural fibers. As we know, it's a very wide world. if we then look maybe at a few other examples of how the system is used to help us with performance fabrics. One example I've used here, in this case, it's a stain repellent fabric such as upholstery fabric, where you want some stain repellency on the top, and then you need to have a good fire repellent back coating applied as a knife coating. In the mill of today, that has to be done first of all by patting the stain repellent and drying it, and then the fabric goes back through again, and this time the latex back coating goes on and everything is polymerized. With spray technology, we have the opportunity, and we have several mills running this, particularly in Turkey. What we can do is we can spray first of all the fabric and run a very low pickup, typically 15% pickup on the fabric, and then in series with the knife coating. So it's a single pass system. So you have a tremendous productivity increase because you only need to go through the center once. Because of the low water uptake in the padding, it will typically run a little faster than it will with padding alone. There's a big, and that's facilitated with a much lower pickup that we run in this application, so up to 70% reduction in water. And importantly, as in all these applications, you eliminate the waste that you're automatically generating when you use the pad. Again, the non-contact, you can reuse the leftover chemistry at the end of the batch. So we have a number of customers running this way, and with good success. Another application is for laminated fabrics. Again, for example, our one of our customers in Italy is producing swimwear, and they would like to have a water repellency on the outside on their laminated fabrics. And again, it's a similar story. We have to apply in the pad, the DWR is applied to both sides. Then you're laminating the fabric, you polymerize the fabric. So there's a lot of steps involved, and there, particularly as we move from C6 to C0, the lamination can be perhaps a little bit more challenging if you have DWR on the face that you're laminating. So with single side spray technology, the lamination portion is done first, and then we apply single side spray to the laminated product, and it goes directly into the stenter where it's polymerized. So again, in this application, the spray technology allows less process steps, so more productivity, increased stenter utilization, better lamination strength because you don't have we laminate before DWR, and again, the elimination of the pad waste. We've been fortunate, we have good customers. I include two examples here of testimonials from our customers. The one on the left is from Mike Abbott at Haynes. They've been a long-standing customer using our system supplies, softeners, antimicrobials in the pads in the Americas. And here in Europe, the testimonial from Fabio at Eurostec. This is the customer, one of the customers that's running the DWR after lamination. So both customers are seeing good sustainability benefits, good productivity benefits. So we'll include that in the deck for you to have a look through later. I'd like to round up the presentation as part of our support to the industry. It's very important that we're able to support our customers with testing, both at laboratory scale and at industrial scale. So I'll give you a flavor for what we have here. We here in Sweden and in Japan, our textile technologist, Janus, based in Sweden. We have the ability to produce A4 size samples, normally customer provided fabrics. So we spray, dry, and cure here in Sweden, and we can run different coverages for you. We can run different concentrations of the chemicals. Let's consider it's recipe refinement ahead of going to industrial scale, and it runs very well. And in the water repellent, stain repellent region, we can run the method 22 spray test and the different alcohol oil repellency tests. We can do that all here in the lab. And as Janus alluded to earlier, we have a separate machine where we can evaluate the shear stability of the finishing chemicals, where we evaluate its ability to be sprayed. And that's an increasing service that we provide the industry. So that's, if you like, the laboratory scale before we go to production. We're very pleased that for our colleagues and our customers in the Americas, we have a partnership with North Carolina State University, where we have installed a 2-meter wide Texcoat dual side in their really very extensive laboratory. It's a very impressive facility. And there we have the ability to run knits, wovens, non-wovens up to 2 meters. And it's in front of a Marshall Williams center frame. And again, we can spray, dry, and cure. And at this stage, it's a proper industrial trial. So that system is fully operational. At our manufacturing site in Lauterbach, where we manufacture not only spray but plasma systems, we've got a very complete roll-to-roll demonstration facility. This is under Alex's supervision, where we can run up to 1 meter fabric width. We can also run plastic films, etc., in this facility. And it's a subject for another day, but in that facility we have the ability to plasma treat the fabric, spray, and then dry the fabric. So it's a very complete facility, and one that we're very proud of. 1 hour north of Frankfurt, so also is very convenient. We also have good partnerships with customers that have our equipment. You know, Eurostick in Italy, I mentioned, is we have the ability to schedule trials with them. We have similar arrangements in Turkey and similar arrangements in Japan. So we have a number of methods by which you can run industrial scale trials. And also, if you want to get up close to our equipment, it's very good news that we're able to be back in the trade show business again, and we're very proud to be back at ITM in Turkey, now 14th to 18th of June, and we'll be exhibiting in Hall 12 on the spot stand, and we're very pleased to see you there. And 1 week later, in Frankfurt, we're exhibiting at Hall 12 at Textile, and we will have show scale Texcoat and also plasma exhibits on our stand. And Rick, Janus, Alex, and I will be very pleased to meet you at both shows. Thank you. So I think that wraps up the main presentation, and at this point I turn it back to the technical team for the questions and answers. Thank you all very much for the time this afternoon. Thank you.
Yeah, appreciate it, Wesley. So while Wesley was making his presentation there, I've had the chat open and the Q&A open, looking for all the questions coming in, and I can say you guys are really lighting us up with good questions, and so we're going to get to as many of those as we can. So I hope you'll continue to hang on for a few minutes and spend a little bit more time with us. First, there were a series of questions that have come through that's really related to dyeing. Okay, and so let's talk about that first. Today, we offer systems for remoistening, which we didn't talk about today, where you need to add some moisture back into your fabric. We have that technology available. The focus of today's presentation is all about finishing and adding low viscosity finishes as a, let's say, as a replacement for the pad. And then all of these dyeing questions have been coming in. Some of the questions are rather specific. So what I'll tell you is today we get questions every day about dyeing, and there's a tremendous amount of folks that are interested in spray dyeing. What I'll tell you today, we don't have a dyeing system commercially available today. We talk to people, we're listening, we've got engineering projects, different things going on, but today we don't have a commercial dyeing solution available. So if you asked a question about dyeing, this is a reason we can't give you a specific answer on that. But we know the market's intrigued about dyeing. We're equally intrigued, but yeah, we'll just have to see what the future brings on that. So what I want to do is make sure we focus answering the finishing related questions. And a couple of the questions, what I'm going to try to do is, let's say, kind of put them together. There was questions related to cleaning and things like that, and I think some of that was answered in the presentation. There were questions about speed and conventional, how it compares to conventional finishing methods. And, what I can tell you, and there was questions about viscosities. So to give you an idea about the viscosities and what we can spray, we definitely showed you that in one of the slides. We talked about the water repellents and softeners and microbials. Those are water-based products. Typically, they're low viscosity, water-like, if you will. As a standard, we say we look to spray materials that are less than 8 centipoise. Okay, that's not the absolute limit, but okay, that's a happy place for us to be, somewhere 8 or south. Someone asked a question about the particle size. For us, maximum particle size is generally around 20 microns. And then, you add to that the pH. Giannis, I think our pH, we like to be somewhere between 4 and 8 on the pH scale. Is that typically what we like to see? And
yes, exactly, Rick. Our range pH is between 4 to 8. The application pH,
okay.
Which is for the most of the finishing applications, is the pH where you have to adjust.
So, we could probably spend 2 or 3 hours talking about more technical details, but just a couple of highlights that maybe we should include that we didn't, that came through in your questions are, what about the speed? How does our speed compare to padding speed? Well, as a general rule, you can run faster with our system than you can with a padding system. Well, why is that? And the reason for that is that generally when you're spraying on the chemistry with our system, you're spraying it on at a higher concentration but a lower pickup. There are some pickup questions in here, about maintaining pickup and with speed and things like that. So let's say you're adding 40 grams per liter of a particular finish, whatever it is, and let's say at 40 grams per liter, I'm just going to say your pickup is 40%. It doesn't matter what the number is. Okay. Well, we'll take that 40 and we'll make it 80. We'll double the concentration as a starting point, but then we'll take that 40% pickup and we'll drop it down to 20. So now you're much drier going into the stinner frame. And if you're drier going in, you can speed it up, you can reduce the amount of heat, There are many things you can do to get more productivity out of it. So as a general rule, you can run faster, not slower with our technology. Let's see, there was a question about, you stated you've got a 3-liter buffer. How do you make sure the consistency of the chemical has the same finishing level for all fabric batch? Well, that's a very good question. We have a 3-liter buffer tank. That buffer tank is connected to your mix supply, whatever the mixing tank that you use that you're currently connected to your pad bath. We'll connect that to our system, and inside of our tank is a pressure sensor that's measuring the level of the fluid inside the tank. So we're always opening and closing the valve to make sure we have the right amount in. And those spray valves are metered. That's a digitally based system. So you can actually control those valves individually if you wanted to. As a general rule, you don't do that. You set the pickup on the HMI, you say, look, I want 20 grams per square meter, and that's what the system sprays. It sprays 20 grams per square meter. And the nice thing is you get that from the beginning to the end of the batch. And what about if my operator increases or decreases the stinner speed? Well, we're taking the speed from that stinner. So if it's increased or decreased, we will automatically adjust that. So there's actually less work for the operator in this case. So I hope that answers that question. I don't want to answer all the questions. I need to give them to the panel. Sorry about that. But let's see. One of the early on questions, and there were a couple of questions related to this, was related to block nozzles. Okay, what's going to happen if you have a block nozzle? So with that, I'd like to turn that over to Giannis and let him explain about how to make sure you don't have block nozzles and what tools we have in place to detect block nozzles.
Thanks, Rick. Thanks. Yeah, actually, I can say that the nozzles do not block during running when the machine is on operation. The nozzle starts blocking when you let the chemistry to be dry. So we actually in our system, in our technology, whenever the machine it stops for a certain amount of minutes, let's say more than 20 to 30 minutes, the spray bars must and the nozzles must flush with water, and we say that like a short flush washing, where you can spray water during the pipes and the spray bars so as to drain the chemistry and replace by the water the spray bars. So, and it does not affect the pump station and the chemical solution which you have on the pump station. So in that way you ensure that the system, after 30 minutes, after 40 minutes, whatever, the nozzle will be free of particles and free of blockage. So except of that, we have an optional flow meter device where you can automatically it can check nozzle by nozzle and can check the flow if it's according to the standard, or if it's below the standard flow, it will raise a red flag that the nozzle number 3 or number 4 it's blocked, and you have to check and clean the nozzle. So in that way you ensure that during the operation of the system the nozzle will be unblocked. Also, as Wesley mentioned on his presentation, there are 3 nozzles overlap each other. So there, even if it happens to have a blocked nozzle, the other nozzle will do the job.
Giannis, I want to stay with you because we had another question here that while we currently don't have dyeing technology at the moment, but this question is related how finishing can have an effect on dyeing or can have an effect on shade. And I know you were at Sklavos for many years as our head dyer, so you have a lot of experience on this firsthand. But the question is, some cationic and non-ionic softeners alter the shades and tones of dyed fabrics. Spraying on one side might lead to back face dyed fabric. Can you explain? And before you explain, first I would say, in these types of applications with softener, we normally spray on both sides anyway. But Giannis, maybe you want to talk about the phenomena of softeners and how it can affect on shade, particularly if it's sitting in the bath, the pad bath.
Exactly, and I would like, Rick, to combine the question with somebody is asking about the color fastness and the color fixation of the fabric. So I would like to say that that question is coming very often when you are visiting a dye house, and as I used to say, it's has nothing to do, the color fastness, the washing fastness has nothing to do with the finishing application. If you ensure that your washing and on the dyeing machine, and you have removed the unfixed dyes, and you have properly washing your fabrics, it's definitely will not affect the washing fastness. Will be the maximum which the dyes can guarantee. Let's say there are dyes which you can have 3 to 4. There are dyes which you can have 4 to 5 or even 5, but all those parameters has to do with the percentage of the dyes, the fixation, and the washing performance. So it's a tradition in the finishing, along with the softening application or whatever you apply, to use a fixing agent also in your chemical bath. The same we can use also in our system. We can spray fixing agent along with the softener. So regarding the shade change, which one of the participants asking, I can say from my experience, we can have even better, let's say, in foulard, that phenomenon is worse than our case, because when you are fully dip the fabric inside the foulard, the amount of the water and the pickup, it's too high. So when we are going to dry, let's say, the high rate of evaporation at the fabric surface leads to those phenomena. As you said, also we can spray on both sides. So personally, I can say that I prefer to spray a little bit more on the surface of the fabric. Let's say 60-40, 70-30. This is depending on the hand feeling of the fabric which you want to have. So in our system, you can have the add-on mainly on the face side, but of course you have the possibility to spray on the back side of the fabric. Another one reason which leads to the shade to shade or meter to meter variation, shade variation, is what Wesley mentioned on his presentation. When the concentration of the chemistry on wet application is going down, when the water from the first foulard is going through the fabric and dilute the concentration of the chemistry on the second foulard, so you have different amount of application when you start, and after some meters. That's doesn't mean that the shade is changing, but your visualization is changing. The chemistry amount, the solids percentage which you have on the fabric is different. So in our application, in the spray application, non-contact technology, we guarantee that from the first meter to the last meter, the amount of the dry chemistry will be exactly the same as the first meters.
Giannis, there was a question about hand feel. So you mentioned hand. So how does the question is, if you're spraying this fabric instead of padding, how does the hand feel from spray compare with that of the traditional pad?
Yeah, I can say that comparing to the traditional pad, especially for heavy GSM fabrics or for fleece, where you want to have a bulky fabric, when you squeeze the fabric at 3 to 5 bars, you just squeeze the fabric through the padders to remove the water and reduce the pickup. You are also let's say destroy the bulkiness of the fabric. So according to my experience, the hand feeling, it's much better comparing to the foulard. It's you can notice when you touch the fabric from the foulard and from a spray application. And from my experience from the exhaust method, I can say that the hand feeling of the spray is similar to the exhaust application method.
Okay, and I want to get Alex in here because I know we're running up close to the end of our hour. There's some couple of questions about applying different finishes on synthetics and lightweight synthetics and tightly woven synthetics, and can the Texcoat manage that? And the short answer to that is yes. I know, Giannis, you were just in Turkey last week doing some tests, some C0 tests on some very similar fabrics. But Alex, I want to go to you. We've got some technology, our plasma treater technology. Maybe you can make a quick comment about that as far as how what a plasma treater is and how it can help with fabrics that don't like to wick the finish.
Yes, Rick. You can say, let's say, a spray technology is always so good, like the textile or the fabric absorbs the liquid here, and the better the fabric or the synthetic fabric or non-wovens even absorbs the liquid. It means a droplet sprayed by any spray technology, the better is the effect. And the plasma is a good thing for pre-treatment before a spray application, because the plasma increases hydrophilic properties of the textile and the fabric, and so this is a good synergy together with spray finishing.
Yeah, I know we brought this in at the very end and really didn't spend any time on plasma treatment. So if there's anybody on the out in the webinar that are having challenges with whatever it is you're trying, whether it's dyeing or finish application, where you're trying to get the fabric to wet out, we have some technology in our toolbox, the plasma treaters, as Alex said, that can help with that. And perhaps in the future we'll have a webinar on that. If you're going to Textile, we'll actually have that technology along with Texcoat on the stand. So we'll be glad to talk with you with that and about that in more detail. Just trying to see here. I know we're at the end of our time. I will. There was one One other question, I think it's important to try to cover it before we run out of time. And somebody asked, is it different from rotor spray finishing? And Wesley, I know you touched on rotor spray just briefly, and you know, I think it's important for the audience because we actually have rotor spray technology, and there are applications where rotor spray definitely makes sense. I would say for the majority of textiles, you know, we offer the text coat because of some of its advantages, but maybe Wesley, you just, you know, in the time that we have left, you can compare and contrast a little bit on that technology.
The rotor spray, it really excels when you want to have exceedingly low coverage, particularly on things like plastic film, metal, etc. And indeed, Alex is our expert on rotor spray here. So it can go to very low coverages, very delicate fabric, very delicate substrates like tissue. There's no better technology, and the rotor spray developed by Alex and his team has much improved uniformity over other systems, other rotor systems in the market. Textile applications tend to require higher coverages, and the one downside of rotor spray is, and it doesn't matter whether it's our rotor or the competitor's rotor, the rotor generates spray 360 degrees of the rotor, and whereas you can only perhaps take 120 degrees of that. So 2/3 of what we spray is automatically recirculated. So for those applications where you have higher quantities, which you typically have in textile, and you've got the shear sensitive requirement, the text coat is a better solution. But I say we are the supplier that offers both technology. We continue to actively develop both technologies, and we see this one is really, this is the strong point here. This one's the strong point here. So I hope that explanation helps a little. And if anyone has further questions, please reach out to us, and look at the right experts with Alex, Yanis, and myself to make a recommendation what's best for your application.
Okay, I think that's all the time we had for questions. We're actually over a bit, Summit, so I'll turn it back to you.
Thank you, Wesley, Rick, and all our panelists for such a great presentation. Thank you to our audience for staying till the end. I hope you all learned through this entire webinar. As we discussed during the Q&A session, we will definitely send out the on-demand video to all our participants and registered users. Meanwhile, you can definitely get in touch with Rick and Wesley over the email. I would request Rick and Wesley to drop in their emails in the chat so that our users can get in touch with you at anytime if they have any questions. With this, I would like to end the webinar. Rick, if you would drop in your email ID
in the chat.
Yeah.
Yeah. Okay. All right. Just a moment. Let me see here. I will do that.
So if anyone has any questions related to the technology, the product, you can get in touch on the email posted in the chat. And with this, I would like to end the webinar. Thank you again for joining today.
Thank you. Thank you
Thank
very
you,
much.
everyone.
Appreciate it.
Thank you.
Thank you.